Now that we know about taxes, we can go ahead and see who's going to be bearing the burden of a tax when it is going to be levied on a good within a particular market. And the specific tax that we talk about is an excise tax. And an excise tax is just a tax that is going to be levied on a particular good. They're also called sort of sin taxes as well, because excise taxes are pretty much going to be placed on goods that are considered sort of sinful. So like cigarettes, alcohol, sugary drinks. So an excise tax is exactly just that. And remember that a tax is going to affect the supply curve, as we told in chapter number 3. And anytime we have an increase in tax, it's going to shift our supply curve over to the left towards the origin, resulting in a higher equilibrium price. However, when we levy a tax, it's going to increase the equilibrium price by less than the full amount of a tax. So if taxes go up by $100, the new equilibrium price that emerges is going to be something less than $100. And the main reason for that is because part of the burden is going to be shifted to the consumers, and the other portion is going to be borne by the producers. And that's exactly what we mean when we talk about the incidence of taxation. Who's going to be bearing more of the price increase due to the tax? Is it the consumers or is it the producers? And the easiest way to go ahead and take a look at this is going to be with an example. So I've drawn up a little bit of a graph right here with a few specific numbers, and we're going to be interested in seeing how this graph changes when we introduce a tax. We have supply, we have demand, our initial supply and demand curves, equilibrium price of $200, equilibrium quantity equal to 3. So this is our original equilibrium. Equilibrium is at point A. We have point A where price is equal to $200 and quantity is equal to 3. So 3,003, whatever it may be, but this is our original equilibrium. So now go ahead and let's suppose that the government is going to impose a $20 excise tax on this particular market. So this is the change that we're going to be introducing. So government imposes a $20 excise tax on this market. So we know that it's going to affect our supply curve because taxes are going to affect supply, and it's going to increase our equilibrium price by something less than $20 just based on what we've said so far. So anytime you deal with taxes, we just go ahead and shift our supply curve by the amount of the tax. So we notice that our supply curve starts on the 170 price axis. So when they impose a $20 excise tax, we're going to go ahead and shift our supply curve left towards the origin by 20 units. So it's going to start exactly at $190 now. So that's all we need to do in order to see where our new supply curve is going to start us off. And then it keeps the same sort of slope, same ratio. So we have S0 plus the tax in this instance. So we notice that our supply curve has shifted over to the left due to the implementation of the tax. And when this occurs, we notice that a new equilibrium price emerges at point B. We'll put this right here. And the numbers that I'll provide to you in this case is going to be $210 and an equilibrium quantity equal to 2. So here we can consider this to be sort of our new equilibrium. So new equilibrium, I'll put that in quotes. Equilibrium emerges. And that's exactly going to be at point B. And the reason why I say it's going to be a new equilibrium in quotes, it's sort of like a pseudo equilibrium, because remember, taxes are never going to be efficient in this sort of case right here. So here, this is going to be the equilibrium that sort of emerges once the tax is imposed on this particular market. And with all of this, we are going to be interested in seeing exactly how welfare and efficiency changes in this particular market. So first of all, we notice that at point B, we have an equilibrium price of $210, and this is the price that consumers pay. So we can go ahead and denote this as a shorthand. Let's put a PC right here. So here, I'll put blue color right here. Blue. So this is going to be a PC right here. So price consumers pay is $210. So PC is equal to $210. And this is the price consumers pay. Price consumers pay. So if the consumers want to buy this particular product, they have to give the suppliers $210. However, the supplier is not going to receive the full $210 because the government is going to take $20 away from that as a tax. So remember, the government is the one that is levying these taxes. So what exactly does the producer receive? They receive $210 from the consumers, but they have to pay the government $20 in taxes. So this is the price producers pay, P sub P in this instance. So P sub P, we see that the producers are going to receive $190. So this is the price producers or the suppliers receive. So in this instance, we notice that, hey, there are sort of two different prices in this case. The price that consumers pay for this particular product and the price that producers actually receive. And that is going to lead to a few implications for us in terms of efficiency. So once again, we can go ahead and find consumer surplus, producer surplus, deadweight loss, and also one additional area now that we have imposed the tax. So let's go ahead and take a look at consumer surplus first. So here, take a look at consumer surplus. So remember, consumer surplus is the area above the price, but below or constrained by the demand curve. The only area that fits with that is going to be this triangle that we have on top right here. So above the price of what consumers pay, which is $210, below our demand curve. So here, everywhere below our demand curve. So everywhere in the green, that is going to be our consumer surplus. So consumer surplus. And once again, it is a triangle, and we know how to find the area of a triangle. So it's 1/2 base times the height. So go ahead and write that down. 1/2 times the base times the height. We know what the base is going to be. It's going to be 2 minus 0. So once again, just taking the distance right here to find all these sort of things. 2 minus 0. And then the height is going to be 230 minus 210. 230 minus 210. And then when we simplify all this, plug this into our calculator, we get a consumer surplus equal to $20. On the other hand, we can also find out what the producer surplus is going to be. And producer surplus, remember, it's going to be the area below the price, but above the supply curve. And this is where we take a look at the price producers receive. The producers receive $190, so it's going to be below this price, but above the original supply curve, which is at 0 right here. And the only area that matches up with that is going to be this gray area that we have. So once again, it's going to be a triangle. We have the base, we have the height. Go ahead and take the distances from all these. So we'll put down producer surplus. 1/2 times the base, which is 2 minus 0, nothing new there, times the height, which is 190 minus 170, 190 minus 170, which also gives us a distance of 20. So therefore, the producer surplus is equal to $20 as well. Once again, because we are not being efficient, because taxes are never efficient in this sort of case right here, point A is sort of our original equilibrium, but we can't reach this equilibrium because we are operating at point B due to the taxes. So therefore, we are being efficient. We do have some type of inefficiency, and the inefficiency is our deadweight loss. And as we said, it's always going to be this triangle that we see in the middle. Before, we were able to sell 3 of these units, but due to the tax being imposed, we're only able to sell 2 of the units, so we lose some efficiency there. And that's going to be this triangle that we see right here. So everything in purple. And once again, it is a triangle, so we can go ahead and find the deadweight loss. Deadweight loss using the same formula, 1/2 times the base times the height. The base is going to be 3 minus 2, so 3 minus 2. And then the height is going to be, as you can see right here, 210 minus 190. It's essentially going to be the amount of the tax. So here, 210 minus 190. So 1 times 20 times half will give us $10 worth of deadweight loss. And you're going to notice from this particular chart, we are missing one giant area, which is going to be seen in the middle right here. So what do you think this part in the middle is going to be for us? Remember, when the tax is imposed, who gets to collect the money from the tax? That's going to be the good old government. And essentially what we have right here, everything in the squiggly lines in yellow right here, that is the area that the government is going to collect as taxes. And there's a few different ways to approach this. If you have a square or a rectangle, you know that the area is going to be length times width. So 210 minus 190 times 2 minus 0. That'll give us $40 worth of government revenues or government taxes. But we can also know that revenues are equal to price times quantity. So we can also do that as well. So government revenues through the taxes, essentially. So easiest way is to do price times revenue, price times quantity. We have the price of the tax being equal to $20. We selling 2 of these units, so 2 times 20 equals to $40 worth of government revenues or taxes. So if you wanted to go ahead and find the area for the government revenues using our chart that we have right here, it'd just be the area for a rectangle or square, length times width, and you use the numbers that we've already said. So length, 210 minus 190, and width is 2 minus 0. So once you go ahead and jot that down, we have the 210 minus 190 times 2 minus 0, and that'll give us $40 as well. So once again, a lot of different ways to approach this, but you'll still get the same exact answer. And with this, we want to go ahead and see exactly who bears what burden of this particular tax. Remember that the $20 tax was imposed within the market, but that led to some different prices for the producers and for the consumers. So here, remember that producers and consumers in this sort of original equilibrium, they were buying and selling and receiving this good for $200. However, we do notice that now consumers are paying $210 and producers are receiving $190. So in this instance, both of these entities are actually sharing the burden of the taxation or the incidence of taxation equally in this case. So here, before they were consumers were paying $200 for this good, but now they're paying $210, so their price has increased by $10. Before, producers were receiving $200 for the good, but now they're only receiving $190. So once again, they have $10 less in terms of the price for this particular good. So in terms of the entire total $20 tax that we have, $10 is going to be paid by the consumers, and the other $10 is going to be paid by the producers or the suppliers. So in this instance, they share the tax burden, equally. And the reason why they share equally in this particular example is because the elasticity of supply and the elasticity of demand, they're actually equal to one another. So here, share tax burden equally, since the elasticities, we can put ED and ES are the same. And if this is ever going to be the case, you notice that the incidence of taxation is going to be divided up equally to the consumers and equally among the producers as well. So this is a very special case of the incidence of taxation that we have right here, but that doesn't always have to be the case. So what happens if we drew our demand curve a little bit steeper, if we made it a little bit more inelastic? What happens if we made our supply curve a little bit flatter, made it more elastic? And that's exactly where the incidence of taxation is going to change, and they don't share the burden of the tax equally anymore. And we'll get a little bit of a closer look at that in our final section.